Okay, so today we're going to look at two videos to explain to you correlation versus causation. Okay, correlation means that two things relate to each other, but causation means one of those things causes the other. So I want you to watch this video really quickly.
A common misconception in statistics is to think that correlation implies causation. Like, if more tall people have cats, you might think that means being tall makes people more likely to get a cat. However, simply knowing a correlation between height and cat ownership can't tell us which way the causality goes. It may instead be that having a cat causes people to grow taller. Or perhaps the real cause is something else altogether, like that the people and cats live on two separate islands, one a lush paradise with enough food for growing tall and feeding pet cats, and the other a wasteland that limits both height and cat ownership. The point of examples like this is that noticing a correlation between two things doesn't imply that one of those things causes the other. Hence the common refrain, correlation doesn't imply causation. And it's true, it doesn't. But this often repeated mantra leads to another common misconception, the idea that you can't infer any causality from statistics. You can. I mean, it's quite reasonable to think that if two things are correlated, there's likely some reason, even if a single correlation can't tell you. Sometimes you can infer the causality from additional information, like knowing that one thing happened before the other, but you can also infer causality directly from correlations. You just need more than one, together with something called causal networks. Like in our cat height island example, we know that cat ownership and height are correlated, but we don't know what the cause of that correlation is. If we don't know anything else, then there are 19, yes, 19 different causal relationships that could explain the situation. 20 if you think the correlation is just an accident. So correlation certainly doesn't imply causation yet. However, perhaps we know two other things. First, suppose people born on a particular island stay there, so their height doesn't influence what island they live on, and we can rule out the relationships where height influences island. Second, suppose that on either island by itself, there isn't any correlation between height and cat ownership. Then we can rule out all the options where height and cats influence each other directly. This leaves us with just two options. Either the islands are the causal explanation for both height and cat ownership, maybe as before one island is a lush, healthy paradise for both people and cats, or else cat ownership is the causal explanation for the islands, which are the causal explanation for height. Like maybe an abundance of cats turned the island into a paradise, thereby influencing the height of future cat owners. So starting with 19 possible causal relationships, we used correlations to narrow things down to just two options. Not bad. And if we knew something about the timeline of when cats and people arrived at the islands, we might be able to narrow it down to just one option. Of course, this is just a simple example, but for any group of things, you can use the various correlations between them, or lack of correlations, to eliminate some of the possible cause and effect relationships. And that's how correlations can imply causation. There is one problem, though. Some experiments in quantum mechanics have correlations that rule out all possible cause and effect relationships. We'll have to save the details for a later video, but until then, here's what that saying really should be. Correlation doesn't necessarily imply causation, but it can if you analyze it with causal models. Except maybe not in quantum mechanics. I've got a little more about statistics.
Okay, so I know that that was really fast and that was a lot of information. But now we're going to look at maybe a more simple video for you to understand what they're talking about.
Like most people, I enjoy a tasty scoop of ice cream, especially Oreo blizzards. But what few people realize is how dangerous a treat ice cream has become. First, there's the issue of obesity. Second, there are higher crime rates. Third, there's the loss of life due to a rise in the number of drowning deaths. And finally, as more ice cream is sold, there's an increase in forest fires. Given these indisputable facts, I need you to support my vision of an ice cream-free world. While banning ice cream trucks from entering your neighborhood may sound far-fetched, when it comes to problem solving, a common issue is misunderstanding the difference between correlation and causation. This misunderstanding can influence our decisions, sometimes with serious consequences that ripple throughout a community. Correlation is when two things are related, but one does not cause the other. Usually this means the two are in some way related to a third factor, but not always. If you have a big enough pile of data, you can find plenty of relationships that are purely coincidental, like the strong relationship between the sale of margarine and divorce rates in the state of Maine. With the sale of ice cream, the third factor is weather. When it is hot outside, people buy more ice cream. They are more likely to go for a swim, and there is a general increase in people out and about enjoying the weather, helping improve conditions for crime to take place, as well as the dry conditions associated with forest fires. A note of caution: there is a growing trend in our digital world called data dredging. This is using analytics to sift through mountains of data, hoping to find useful relationships. Instead of a problem in search of a solution, dredging data is a solution looking to find a problem. All of what I've just discussed about correlations does not mean that finding a correlation is without value. In fact, correlations are a vital part of helping us move to the next step, the discovery of causation. Unlike correlation, causation is when you can claim that one thing causes another thing to happen. In order to make this claim, you need to be able to demonstrate an actual cause and effect relationship, preferably a strong relationship. An example most of us are familiar with is the pharmaceutical industry. In order to make the claim that a particular drug causes a certain effect, such as lowering your cholesterol or growing hair, the FDA requires companies support those claims, putting the drug through a 4-phase, 12-step process that takes approximately 12 years. This process uses control groups and clinical trials to test the drug, making sure that X causes Y and that the drug is safe. The acceptable error rate can go as high as 5% for some drugs, meaning that the clinical trials prove that there's a 95% chance the drug does what it claims. Drugs with serious health implications, such as those used to treat a heart condition, are held to an even stricter standard, requiring proof up to 99% effectiveness. Back to ice cream. What about ice cream and obesity? While it may seem like common sense that it does cause obesity, the fact is that we don't yet know the true strength of the relationship. If we look at the sale of ice cream, there's actually an inverse relationship with weight. People gain weight in the winter when sales are low and lose weight in the warm summer months when more ice cream is being consumed. This might suggest ice cream is the new diet food. Luckily, you now know to be cautious of drawing conclusions of causation from correlation. Instead, recent research on the subject has been looking at different types of sugars used in making a wide range of sweet foods. What scientists have discovered is that the hypothalamus, which is an area of the brain that regulates the human appetite, reacts differently when we consume foods with fructose instead of glucose. This has researchers speculating that eating high fructose foods, such as ice cream, may result in people not feeling full, so they continue to eat. This theory proves difficult, however, when we start considering apples and other natural fruits also contain fructose, not just ice cream and chocolate cake. As you can see, causation is quite a bit different than correlation. Finding correlations is easy, proving causation is hard. No wonder it takes 12 years just to prove that a pill causes hair to grow. The bottom line: on the news, in boardrooms and coffee shops, everywhere you go, you will hear claims that X causes Y. From politics to the weather, from the stock market to personal relationship, it is human nature to try and explain things, to create stories that make sense. Just keep in mind, as you hear a claim of what causes what, that correlation is not causation.
Okay, so that was all just to show you that something can correlate, but that doesn't mean that they cause the other. So it's like saying, as ice cream sales increase, drownings increase. Okay, so that would be a positive correlation. Okay, but does that mean that ice cream causes the drownings? No, like they said before, it was maybe just the weather, the time of year. There's more swimming in that time of year. There's more ice cream sales in that time of year. It doesn't necessarily mean that the ice cream causes the drownings. So what you're going to do is you're going to answer the next 5 questions on your paper, and I want you to tell me if they're a correlation or a causation. Good luck. Once you finish, I want you to start doing some makeup work. Grades are due actually today.